Hello everyone, we are now in the lesson 2.1 and today we are going to discuss the formation of behavioral elements during star formation and evolution. And first, we are going to discuss the nucleosynthesis. Nucleosynthesis is the beginning of elements. Before we proceed, let's read the objective first. At the end of the lesson, you should be able to give evidence for and describe the formation of heavier elements during the star formation and evolution. In the previous lesson, you have learned how the light elements hydrogen, helium, lithium, and beryllium were formed during the Big Bang nucleosynthesis. How were elements heavier than beryllium formed? Let's learn about it. Elements heavier than beryllium are formed through stellar nucleosynthesis. Stellar nucleosynthesis is the process by which elements are formed within stars. The abundance of these are elements change the stars evolve. Evolution of star. The star formation theory proposed that a star formed due to the collapse of the dense region of a molecular cloud. As the cloud collapsed, the fragments contract to form a stellar core called protostar. Due to strong gravitational force, the protostar contracts and its temperature increases. When the core temperature reaches about 10 million K, nuclear reactions begin. The reactions release positrons and neutrinos, which increase pressure and stop the contraction. When the contraction stops, the gravitational equilibrium is reached and the protostar has become a main sequence star. In the core of a main sequence star, hydrogen is fused into helium via the proton-proton chain. When most of the hydrogen in the core is fused into helium, fusion stops and the pressure in the core decreases. Gravity squeezes the star to a point that helium and hydrogen burning occur. The helium is converted to carbon in the core, while hydrogen is converted to helium in the shell surrounding the core. The star has the becoming a red giant. Inert carbon. A massive star has enough mass such that temperature and pressure increase to a point where carbon fusion can occur. The element oxygen is formed from carbon fusion, neon from oxygen fusion, magnesium from neon fusion, silicon from magnesium fusion, and iron from silicon fusion. The star becomes a multiple shell red giant. Learn about it. The fusion of elements continues until iron is formed by silicon fusion. Elements higher than iron can be fused because when two of these elements combine, they produce a nucleus with a mass lower than the sum of their masses. The missing mass is released as energy. When the core can no longer produce energy to resist gravity, the star is doomed. Gravity squeezes the core until the star explodes and releases a large amount of energy. The star explosion is called supernova. The red giant star. A red giant is a star in the later stages of its stellar life. It is said that stars only spend 100% of their lives in this stage. Our Sun is now in the main sequence. It generates energy by converting hydrogen into helium. Red giant stars have different ways of generating their energy. There are three groups of them in giant branch. The red giant branch or RGB, the horizontal branch or HB, and the asymptotic giant branch or EGV. How do stars evolve? Due to fusion, star evolved due to two factors, gravity and pressure. The star collapses when gravity exceeds pressures, and the star expands when pressure overcomes gravity. The evolution of star is driven by nuclear fusion and fission events in the star. The mass of the star determines their final stage. How are stars created? All matter with mass bend space-time in a way that causes other nearby mass to be attracted. We call the force that regulates that attraction gravity. The gravitational force between any two objects is defined by the equation below. The equation is a constant, so the variable are the masses of the two objects and the distance between their centers. So imagine a vast cloud of gas, primarily hydrogen, since that is the simplest atom. Eventually, we get to the point where we have a condensed mass where there is a little room for movement. The molecules at the center are all under pressure from the weight of the molecules farther out that are trying to get to the center. The sheer number of atoms is mind-boggling. In this scenario, our sun, and not particularly large, has about 1.2 E57 atoms. It takes about 837 E55 hydrogen atoms to crash together and create enough heat to kick off the fusion. One interesting thing is that if fusion did not initiate, the mass would keep condensing until it collapsed. The heat from fusion creates a counting force that keeps the star stable. And that's the end of our discussion. Thank you so much everyone and have a good day.